Hello everyone, this is João from CanHub and welcome to another anatomy tutorial where this time we're going to be talking about the liver in situ. So what we're going to be doing is exploring this image that you see now on the screen, which is the interior view of the abdomen. Now you see here on the image that we're using some tools to then retract the liver to then expose some of the structures that you find that are neighboring structures. We're going to look at some of these structures and just describe them. As you know, the liver is a large central organ that you find on the upper right quadrant of the abdomen, extending into the upper left quadrant to be more specific. Well, it is a multifunctional accessory organ of the gastrointestinal tract that performs functions such as detoxification, protein synthesis, biochemical production, and nutrient storage. And for this reason, it is also referred to as the chemical factory of the body. Now, the liver consists of 4 anatomical lobes, which are further divided into smaller segments according to the blood supply of this organ. In this tutorial, we will only cover the sections of the liver seen from the coronal plane of the abdomen, while looking at the structures that can be seen in relation to the position of the liver in situ in this plane. So we're going to be exploring the different structures you see here on this image. So in other words, also we're going to be describing the liver and the surrounding structures from an interior view as seen when the anterior abdominal wall is removed. The first structure we can see here, and we're going to be highlighting in green, this is the left lobe of the liver. And here we then see the left lobe highlighted in green, the left lobe of the liver, whose right border corresponds to the line connecting the inferior vena cava and the fundus of the gallbladder. As you can see on this illustration, this lobe is smaller than the right lobe, as you can see here, and is located in the left epigastric and hypochondriac regions beneath the diaphragm. Now if I move on here to this image where I just remove the stomach, also remove the greater omentum, the lesser omentum, and the transverse colon, you can see how the left lobe of the liver relates to some of the structures that we're going to be describing. Next structure we're going to be highlighting here, as you can see on both of these images, is then the right lobe of the liver. From this section, the only other lobe of the liver we can see is the right lobe of the liver, whose border on the left corresponds to the line connecting the inferior vena cava and the fundus of the gallbladder. We can see here in this illustration the larger right lobe of the liver pulled up, showing then 2 ligaments that keep the liver in its position. The first one is known as the falciform ligament, which you see here highlighted on this image. This one attaches the liver to the anterior abdominal wall. And the other ligament that you see here is the round ligament of the liver on the right side, which separates the right and left lobe in the visceral surface of this organ. On the next image, we're going to be highlighting here a part of the pancreas, or 2 parts of the pancreas, the body and the tail. So here you find the body or the tail of the pancreas. Now this is the part of the organ whose anterior surface faces the front of the abdomen. Now the body of the pancreas is not clearly visible because it lies in the loop of the duodenum. Now the tail of the pancreas lies near the hilum of this organ here, the spleen. So as I mentioned on the previous slide, the tail of the pancreas lies very close to the spleen that we see now highlighted in green. The spleen is a lymphatic organ, and it sits to the left side of the abdomen beneath the diaphragm, which you see a little bit here. Next, we're going to be highlighting this structure here, which is known as the gallbladder. We see here the inferior surface of this small but important organ, the gallbladder. It is located just beneath the right lobe of the liver, lodged in the fossa of the gallbladder. This hollow organ serves as a reservoir for bile produced in your liver. Now, in between meals, the bile produced by your liver is then stored in the gallbladder, and after a meal, a dose of bile is then secreted from the gallbladder into the duodenum to facilitate digestion. Now, the gallbladder receives blood supply from the cystic artery and receives sympathetic innervation from the celiac ganglion and parasympathetic innervation from the 10th cranial nerve, vagus nerve. Now, a common clinical point associated to the gallbladder is known as cholelithiasis, more commonly known as the formation of gallstones. Now, this occurs as a result of the crystallization of biliary constituents that form into then the gallstones. Another structure I would like to highlight here that we see on this image is known as the cardiac orifice of the esophagus. Now, this is a neighboring structure in relation to the liver. This is the opening of the esophagus into the cardiac part of your stomach. Now, in this illustration, we see that the body of the stomach has been removed. Now, the abdominal part of the esophagus lies just behind the posterior surface of the left lobe of the liver, and during its course, it forms an indentation on the posterior surface of the left lobe, known as the esophageal impression. A gastric impression is also seen on the left lobe caused by the contact of the stomach with the visceral surface of your liver. Another structure we're going to be highlighting here on this image is known as the pyloric part of the stomach. With the body of the stomach removed, the next portion of the stomach that we can see in relation to the liver is then this one that we just highlighted, which is the pyloric part of the stomach. And next, we're going to be highlighting this structure here, which is known as the superior part of the duodenum. Now, just after the pyloric part of the stomach is the superior part of the duodenum. The duodenum is a C-shaped loop that makes up the first part of the small intestines. Now, the superior part of the duodenum is located horizontally and is the first part of the duodenum. Do not forget this. Now, it contains a dilation known as the ampulla, which you see here highlighted in green on this image, where you have here then the duodenum, or a section of the duodenum, bit of the pancreas here, and it lies inferior to the right lobe of the liver, causing then an impression on the liver known as the duodenal impression, for lack of a better name. The next structure we're going to be highlighting here on this image is the horizontal part of the duodenum. This is the horizontal segment, which then begins at the inferior duodenal flexure and passes in front of the inferior vena cava, the abdominal aorta, and the vertebral column. As you can see here, it is located below the head of the pancreas. You see a bit of the head of the pancreas here on this image. And please note that in total, the duodenum is made up of 4 parts: the superior part, which we have already discussed, a descending part, a horizontal part, and an ascending part. But we're going to look at the duodenum in a little bit more detail, but on a separate tutorial. But all these parts make up the C-shaped look in which the head of the pancreas then lies. You can also see here this image where we show you the highlight of the full horizontal part of the duodenum. And notice how the head of the pancreas then lies on this area. The next structure we're going to be highlighting here on this image is known as the duodenojejunal flexure. Now, this is the junction between the duodenum and the jejunum of the small intestine, which is then known as the duodenojejunal flexure. Located just below the inferior surface of the pancreas, this structure is covered in front as well as partially on the sides by the peritoneum, which is then continuous with the left portion of the mesentery. The duodenojejunal flexure is surrounded by a fold of peritoneum, which contains muscle fibers called the suspensory ligament of the duodenum, also known as ligament of Treitz. Now, this ligament is an anatomical landmark used by anatomists and surgeons to then locate the duodenojejunal flexure and the point where the small intestine passes from the retroperitoneal duodenum to then the intraperitoneal jejunum. You can see this structure a bit more clearly here on this image, where you can then see the full duodenum, or a section of the duodenum and a bit of the jejunum. Next, we're going to be highlighting this structure here, which is known as the right colic flexure. Now, this is a portion of the large intestine, which also relates directly to the liver. Here we see then the sharp band between the ascending colon and the transverse colon, known as the right colic flexure. It is also referred to as the hepatic flexure, as it is located adjacent to the right lobe of the liver. A colic impression is then formed on the liver as a result of the contact of the colon with the visceral surface of the right lobe. The next structure we're going to be highlighting here on this image is known as the transverse colon, which is the transverse section of the large intestine located between the left and right colic flexures. Now, this is the longest and most movable part of the colon. Its upper border is in relation to the liver and the gallbladder, as well as the greater curvature of the stomach, and it is located almost completely intraperitoneally. You can see here then a cut on this image of the transverse colon. Now, moving on to this highlight here, this is known as then the left colic flexure, which is also referred to as the splenic flexure due to its proximity to this organ here, the spleen. It is the sharp junction on the left side between the transverse colon and the descending colon located in the upper quadrant of the abdominal cavity. Next, we're going to be talking about a ligament that you see here highlighted in green, the hepatoduodenal ligament. So now that we have discussed the viscera that can be seen when we look at the abdomen in the coronal plane in relation to the liver in situ, after the removal of the stomach, small intestine, and part of the transverse colon, let's move on and look at the ligaments that are related to it. Starting with this one, then, the hepatoduodenal ligament, which is part of the lesser omentum between the porta hepatis and the superior part of the duodenum, known as this ligament. This ligament also attaches the duodenum to the liver. The proper hepatic artery, the hepatic portal vein, and the common bile duct run inside the hepatoduodenal ligament and are commonly referred to as the portal triad, which you see here highlighted in green. Now, the hepatogastric ligament is the second part of the lesser omentum, forming its cranial part. Now, this ligament extends between the liver and the lesser curvature of the stomach and then transmits both the left gastric artery and the left gastric vein. Next, we're going to be seeing here what is known as the round ligament of the liver, which is the connective tissue representation of the remnant of the umbilical vein, and it divides the left lobe of the liver from the medial and lateral sections. It exits from the free edge of the falciform ligament and inserts around the umbilicus. The next ligament that we're going to be highlighting here is known, and you see here a zoomed or magnification of this ligament. This is known as the gastrosplenic ligament. This one is not directly related to the liver, but can be seen here on this image, so it's important to also cover it. So the gastrosplenic ligament, which is part of the greater omentum and stretches between the greater curvature of the stomach to the hilum of the spleen. Now, this ligament contains the short gastric vessels and the left gastric epiploic vessels. And if we isolate here the spleen on this image, you can then see the gastrosplenic ligament highlighted. Next, we're going to be highlighting here this foramen, which you see here. Notice this foramen here, which is known as the omental foramen. This one allows for communication between the greater peritoneal sac and the lesser peritoneal sac, or basically it allows for communication between the general cavity and the omental bursa. This foramen, also known as the epiploic foramen, is bordered anteriorly by the hepatoduodenal ligament, posteriorly by the peritoneum of the inferior vena cava, superiorly by the caudate lobe of the liver, and the peritoneum of the first part of the duodenum and the hepatic artery inferiorly. On the lateral side, it is then bordered by the gastrosplenic and splenorenal ligaments. Another thing we can see here, and we're going to highlight now, is part of the greater omentum. This is another important structure, which is a double-layered apron-like fold of visceral peritoneum that is fixed to the greater curvature of the stomach and the first part of the duodenum. It hangs down and reflects back on itself, ascending to attach inferiorly to the transverse colon. The greater omentum is divided into or subdivided into two parts, namely the gastrocolic ligament, which is the part between the stomach and the transverse colon, and the gastrosplenic ligament, which is the part between the stomach and the spleen. Now I can show you here another image where you see the greater omentum. Next, we're going to be highlighting here the mesentery, which is a dorsal peritoneal fold arising from the posterior wall of the peritoneal cavity that provides fixation from the intraperitoneal small intestine. Now, vessels and nerves that supply the small intestine are then transmitted within the mesentery. The mesocolon refers to the part of the mesentery close to the large intestine, but for more information on the structure, we're going to be covering on a separate tutorial here at CanHub. Finally, we're going to be highlighting here this part, which is known as the root of the transverse mesocolon. This part of the mesentery is attached to the transverse colon and then transmits vessels and nerves that supply the colon. Now that you just completed this video tutorial, that is time for you to continue your learning experience by testing and also applying your knowledge. There are 3 ways you can do so here at CanHub. The first one is by clicking on our Start Training button. The second one is by browsing through our related articles library. And the third one is by checking out our atlas. Now, good luck everyone, and I will see you next time.